We're taking a look here at graphing a piecewise function. You may have guessed that a piecewise function is called a piecewise function because it comes in more than one piece. And here we have a function which actually comes in two pieces. So there's two different values for the function. So first, we have a value of 5 minus x wherever our x coordinate is less than or equal to 2. And the second piece is where f of x is equal to x minus 1, wherever x is greater than 2. So it looks like we have this dividing point whenever our x coordinate is 2. So we approach this in two steps. The first step, we're going to find some points and graph our first equation. And the second step, we're going to find some points and graph the second equation. So let's go ahead and let's take that first equation, 5 minus x, and let's find some points. So I'm just going to draw a little chart here. So let's think about our values of x. If we look at our restriction, x has to be less than or equal to 2. So let's start with a value of 2 for x, and let's plug that into that equation, 5 minus x. So 5 minus 2 is 3. Now our restraint, remember, is that x has to be less than or equal to 2. So we can only go down from here. So let's just go down to 1. Let's make it easy on ourselves and pick easy numbers. Plug in a 1. 5 minus 1 is 4. And let's do one more. Since this is just a line, a linear equation, we should be able to graph it with 3 points pretty easily. So plug in a 0 for x, and we get 5. So there's all the points that we need to graph that first equation, and let's go ahead and graph it. So we want to take those points and plot them on our graph and then draw that line. So we've got 3 points here that we can plot. We've got where x is equal to 2 and y, or f of x in this case, is 3. And then we have where x is 1, so our f of x is going up to 4. And then finally, when x is 0, we're up here at 5. Now this line only goes in one direction. It only goes up, and it stops right here where x is 2, and that's because, again, of our constraint that x is less than or equal to 2. Now, since x is less than or equal to 2, that x-coordinate of 2 is actually included. So to show that, I make a solid dot there at the beginning of the line. That's our first piece. Let's go on and let's graph our second piece. So again, we need to find some points. So x and f of x. So here we see that x has to be greater than 2. Now, even though 2 is not included, let's just see what it would be if x were included. So if x is 2, then x minus 1 is 1. Now we see again, x has to be greater than 2, so our values can only go up from there, so we'll make it easy and just use whole numbers. So plug in a 3 for x, and let's plug in a 4 for x, just for good measure there. So if we look at these points, that first point is not actually included, but when x is greater than 2, it can start just a teeny fraction right after 2. To just show that, we do an open circle at that point. So at that point where x is 2 and f of x is 1, we make an open circle, if I can do this here. And then when we plot the other points, when x is 3, y is 2. When x is 4, y is 3. And so our second line is going to go something like this. So now you've graphed your piecewise function. We had two different equations here. So we had our 5 minus x, and we plotted that. There's our 5 minus x, and we should really put f of x is equal to 5 minus x. And the second equation, f of x equals x minus 1.